Hey everyone, so I bring you some new science news from Ohio State. This is Ohio State news. We have a 30 million year old amphibious beaver fossil. Is the oldest beaver ever found. The newly identified species did not have the flat tail that helps modern beavers swim today. Micratheriomas Articulaquaticus, what a name, was comparably small, weighing less than 2 pounds. Modern adult beavers, on the other hand, like the one above photographed in Minnesota, weigh 50 pounds or so. Ankle bone analysis reveals when beavers evolved to swim. Huh, very cool. All right, let's get into this. A new analysis of a beaver ankle bone fossil found in Montana suggests the evolution of semi-aquatic beavers may have occurred at least 7 million years earlier than previously thought, and happened in North America rather than Eurasia. In the study, Ohio State University evolutionary biologist Jonathan Khalid, sorry if I'm mispronouncing your last name, bro, describes the find as the oldest known amphibious beaver in the world and the oldest amphibious rodent in North America. He named the newly discovered species Micratheriomas Articulaquaticus. Khalid's findings resulted from comparing measurements of the new species' ankle bone to about 340 other rodent specimens to categorize how it moved around its environment, which indicated that this animal was a swimmer. The Montana-based bone was determined to be 30 million years old, the oldest previously identified semi-aquatic beaver. Wrong tone on that sentence. The oldest previously identified semi-aquatic beaver lived in France 23 million years ago. Beavers and other rodents can tell us a lot about mammalian evolution, said Khalid, an assistant professor of evolution, ecology, and organismal biology at Ohio State's Marion campus. He says, quote, "Look at the diversity of life around us today, and you see gliding rodents like flying squirrels, rodents that hop like the kangaroo rat, aquatic species like muskrats, and burrowing animals like pocket gophers. There is an incredible diversity of shapes and ecologies. When that diversity arose is an important question. Rodents are the most diverse group of mammals on Earth, and about 4 in 10 species of mammals are rodents. If we want to understand how we get incredible biodiversity, rodents are a great system to study." So the article gives us a link to the article, which we'll take a look at in just a second. But let's finish this one. The scientists, including Khalid, who found the bones and teeth of the new beaver species in western Montana, knew they came from beavers right away because of their recognizable teeth. But the discovery of an ankle bone, about 10 millimeters long, opened up the possibility of learning much more about the animal's life. The astragalus bone in beavers is the equivalent to the talus in humans, located where the shin meets the top of the foot. Khalid took 15 measurements of the ankle bone fossil and compared it to measurements, over 5,100 in all, of similar bones from 343 specimens of rodent species living today that burrow, glide, jump, and swim as well as their ancient beaver relatives. Running computational analyses of the data in multiple ways, he arrived at a new hypothesis for the evolution of amphibious beavers, proposing that they started to swim as a result of exaptation, the co-opting of an existing anatomy, leading in this case to a new lifestyle. In this case, the adaptations to burrowing were co-opted to transition to a semi-aquatic locomotion, he said. The ancestor of all beavers that have ever existed was most likely a burrower, and the semi-aquatic behavior of modern beavers evolved from a burrowing ecology. Beavers went from digging burrows to swimming in water. It's not necessarily surprising because movement through dirt or water requires similar adaptations in skeletons and muscles. That's really interesting. I never thought of it that way, but now that he's explained it this way and made this comparison and I'm visualizing it, it makes a lot of sense. That's really cool. Fossils of fish and frogs and the nature of the rocks where Micratheriomas Articulaquaticus fossils were found suggested it had been an aquatic environment, providing additional evidence to support the hypothesis, Khalid said. Now, fossils are usually dated based on their location between layers of rocks whose age is determined by the detection of the radioactive decay of elements left behind by volcanic activity. But in this case, Khalid was able to age the specimen at a precise 29.92 million years old because of its location within, rather than above or below, a layer of ashes. The oldest semi-aquatic beaver we know of in North America before this was 17 or 18 million years old, he said, and the oldest aquatic beaver in the world before this one was from France and is about 23 million years old. Now, I'm not claiming this new species is necessarily the oldest aquatic beaver ever, because there are other animals that we know from their teeth that are related to this species I described. Micratheriomas Articulaquaticus did not have the flat tail that helps beavers swim today. It likely ate plants instead of wood, and was comparably small, weighing less than 2 pounds. The modern adult beaver, weighing 50 pounds or so, is the second largest living rodent after the capybara from South America. Khalid's analysis of beaver body size over the past 34 million years suggests beaver evolution adheres to what is known as Cope's rule, which posits that organisms in evolving lineages increase in size over time. A giant beaver the size of a black bear lived in North America as recently as about 12,000 years ago. Wow, I didn't know that. That's crazy. Could you imagine getting attacked by a beaver the size of a black bear? You think black bears have big teeth. Imagine a beaver the size of a black bear. Has those iron-reinforced orange fangs that would be like the size of your shoes. That'd be crazy. Okay, they say, like all but the 2 beaver species living today, Castor canadensis and Castor fiber, the giant beaver is extinct. It looks like when you follow Cope's rule, it's not good for you. It sets you on a bad path in terms of species diversity, Khalid said. We used to have dozens of species of beavers in the fossil record. Today we have 1 North American beaver and 1 Eurasian beaver. We've gone from a group that is super diverse and doing so well to one that is obviously not so diverse anymore. Unquote. All right, well, this is a pretty cool little finding about this ancient beaver. Let's look at the study real quick. I'm not going to go through the whole thing because it's, again, very technical, and we just read that pretty good article about it. But what did they say here in the abstract? The North American rodent fossil record includes hundreds of species representing both an incredible taxonomic diversity and great ecological disparity. Although it is during the Oligocene that taxonomic diversity first peaks, it is not until the Miocene, almost 10 million years later, that many ecologies, particularly locomotor ecologies, are recorded. Here I present a new Oligocene-age species of beaver from Montana, Micratheriomas Articulaquaticus, which represents the oldest semi-aquatic rodent in North America and the oldest amphibious beaver in the world, pushing the advent of semi-aquatic ecology in beavers back by 7 million years. I also provide morphological data supporting a terrestrial ecology for the sister taxon to Castoridae. Together with the existing data, these findings lead to a new hypothesis for the evolutionary ecology of castarids, whereby swimming was exapted from burrowing during the Oligocene. This evolution of semi-aquatic locomotion may have taken place in North America instead of Eurasia. It started in small beavers, with the gigantism achieved only much later. Indeed, body size evolution in castarids follows a directional drift. Beavers obey Cope's rule, a selection for larger size over time that appears associated with semi-aquatic ecology and may well explain their low modern diversity. Now there's a small detail that I just wanted to touch on real quick. He provides morphological data supporting the terrestrial ecology with the sister taxon to Castoridae. So the Castoridae contains the beavers, and their sister taxon is a more terrestrial clade. And so by comparing them, he sees, this ancient species does have a lot of similarities to that terrestrial sister taxa. So you can see how they diverge. They were on land burrowers who then diverged to this more semi-aquatic lifestyle and became swimmers. So here's some of the bones he looked at. Here it looks like a jaw. I'm not quite sure what these are. Oh, just different views of teeth, dentary bones and stuff. Okay. Material diagnosis of species. Much smaller. This is always interesting, like how they determine the species from the fossils, because you'd think it'd be very difficult because you just have the bones. And it is difficult, not trying to underplay paleontology or anything, but it is really, really cool how bones have these tiny little subtle features and traits that you can compare across, fossils from different time periods and see how they change, how they move, how they grow, how they adapt or disappear. And this lets you group them according to, if not species, by genera, by genus. And it's just really, really cool stuff. So what they say here is much smaller than Anchitheriomus, Oligotheriomus, and Myotheriomus, only slightly smaller than M. brevirinus, rostrum shorter than... it's not like a written paragraph. They're just listing off a lot of the morphological differences. Okay. Incisors with rugose enamel surface but not ridged. Cheek teeth unilaterally hypsodont, upper tooth rows parallel to one another. So if you're ever wondering like how paleontologists like place fossil species, this is how they do it. They examine like teeth and the bones, all these different features. Really cool stuff. Results. There we go. Phylogeny. Interesting. Wow. Castorides dilophytus was a giant one. All right, well, very long discussion. Not going to read all of that. But yeah, very cool study looking at the evolution of beavers. They went from burrowers on land to swimmers in a semi-aquatic habitat. And then after that, they grew larger and larger, probably as a result of being in their aquatic habitat. And this retarded their biodiversity. Yeah, that ended up with the beavers we see today, just the two species. Cool stuff.